Here's the next question, number 48. A single-phase bidirectional voltage source converter, VSC, is shown on the figure below. All devices are ideal. It is used to charge a battery at 400 volts with power of 5 kilowatts from a source, Vs, 220 V RMS, 50 Hz sinusoidal AC mains at unity power factor. If its AC side interfacing inductor is 5 millihenry and the switches are operated at 20 kHz, then the phase shift delta between AC mains voltage and fundamental AC RMS voltage in degrees is dash. Okay, so here in the figure we have been given a single phase bidirectional voltage source converter. And if we were to draw the phase diagram of the information given to us, we see that they are asking the phase shift delta between AC mains voltage Vs and the fundamental RMS voltage Vc1. So this is the angle between both of these voltages is what we are supposed to find. Now in order to do that, let's write down all the given information first. We have been given the charge of the battery at 400 volts, the power utilized at 5 kilowatts, the source voltage, RMS voltage at 220 volts, 50 Hz, and the inductor value is given as 5 millihenry. Okay, so I believe this is all that we require. Okay, let me just get another sheet of paper and we'll write it down. Okay, so the given data, given information. So we have the voltage of the battery as 400 volts. The power utilized is 5 kilowatts. 5 into 10 power 3 watts. And then we have the source voltage RMS at 220. And the power factor is unity. So when power factor is unity, cos phi is equal to 1. And the inductor value is also given to us as 5 millihenry. So that's 5 into 10 power minus 3 Henry. Okay, so I'll just put down the phasor diagram here. Okay, so this is the angle delta. Here is the source voltage and here is the voltage of the converter, RMS. And here we have IS, XS, where this is the source current and the source reactance. Okay. Now, the next part is to utilize the power formula. We know in general that the power formula is given as VI cos phi for AC. And in this expression, we are going to work on the source. So it is Vs, Is, cos phi. Now let's calculate what Is is from this equation here. So the power is given to us as 5 kilowatts. So let's substitute the values. 5 into 10 power 3 is equal to, Vs value is 220. We need the value of Is and cos phi is 1. So from this we find out what Is is. Is is 5 into 10 power 3 divided by 220. And that comes to 22.72 amps. So this is the value of the source current. Now let's look at the triangle over here. If we were to find out what delta is, we can use tan. Let's use tan here. So tan delta. Tan delta would be opposite by adjacent value, right? So tan delta is equal to, now the opposite is ISXS divided by VS according to the figure there. Now let's take tan to the other side since we are supposed to find out what delta is. So we get here delta is equal to tan inverse of IS. Now we need XS too, right? So XS can be written as 2 pi FL. Since we have, look at the figure here, we have an interfacing inductor. right? So if we are to write down the reactance of the source, we write it in terms of inductance, L. So 2 pi FL divided by Vs. Now I'll just write down the rest over here for you. So we have delta is equal to tan inverse of Is is 22.72. 2 pi FL would be 2 times 3.14 times 50, since that's 50 hertz, into 5 into 10 power minus 3, all divided by 220. I hope that's all right. You follow, right? So it's Is into 2 pi FL divided by 220. So the tan of this entire thing will give us a delta value of 9.209 degrees. So this is the final answer. Since this is not a multiple choice question, the final value would be 9.209. Well, I hope this has helped.